Hey, Sterling here from Vegas Nerve Stimulation and Repair. Today we're going to talk about a really cool and very out there, very advanced application for ultrasound for stimulating the body, stimulating nerves. So we're going to be talking about MEMS, which is micro electromechanical systems. These are things that are fabricated on the very, very small scale that enable you to essentially implant electronics into the human body. So this is where a lot of this work is going. We're already seeing companies like Neuralink doing implantation of electrodes into the human brain with electrodes and systems that are fabricated on chip, which means that the same technology that can make a CPU can just make the neural stimulation electrodes, and all you need to do is just seal it up and plant it and put it into the human body, and then you have an implant. No complicated extra features or anything like that. So very, very fascinating world. But yeah, MEMS ultrasound is a subject that's been around for a long time, maybe the last 25 years. Some fabrication has been happening on that level, very microfabrication. But this is a paper that we're going to look at where we talk about what the latest is. Like, this is a paper from 2019, and so I want to see what's possible. So this paper is from nature.com, published on basically the section on MEMS. So the abstract here briefly is neuromodulation by ultrasound has recently received attention due to its non-invasive stimulation capability for treating brain disease. Although there have been several studies related to ultrasonic neuromodulation, these studies have suffered from poor spatial resolution of the ultrasound and low repeatability with a fixed condition caused by conventionalized and commercialized ultrasound transducers, meaning these transducers used are big and they're placed outside of the brain, outside of the skull, meaning that focusing and having repeatability is actually quite difficult to do. So in this, they're introducing a kind of a system where you could implant an ultrasound device in a specific subcortical region in the brain, or in different parts of the body, or in cell cultures specifically. So you could fashion a petri dish with neurons growing on top, where the ultrasound stimulator was embedded in the petri dish itself, that was so small that there's no tolerance for moving of that transducer. So, and you could specifically target just a few cluster of neurons at a time. So that's what this paper is all about, and this details the entire process of successfully creating a MEMS ultrasound system and then successfully stimulating these neurons with it. And so they relate back to some of the old papers on stimulation with ultrasound. But here's a great illustration. So in part A, we talk about a PMUT array, which is multiple layers of ultrasound channels that are able to be individually addressed, and then a cell culture plate. So you can see that in part B, you can see if they stimulated channel 2 with ultrasound, that it would stimulate a certain section of stimulated cells of neurons, and then they could stimulate additionally at a different point in time channel 5 and stimulate different cells. Now in part C, you can kind of see how it looks if it's put upside down, and you can see how the whole thing is put together and how neurons would be cultured on top of this medium. So very cool PMUT specific device. So then they go into the fabrication. They talk about the frequency. So initially they set the resonant frequency of the transducer to 500 kilohertz, but they actually shifted down to, I believe, 430 kilohertz. So 500 kilohertz to a lower frequency, actually, just due to the thickness and the materials available. Here's another diagram of what it looked like when it was fabricated, how small it is, how the membrane looks, what the whole system looks like, and how you can connect it to a specific system. But this is a nickel. So if you think about the size of a nickel, you can put how many of these electrodes are there? 12 or 16? So there's 16 electrodes on this one strip, which is a fraction of the size of a nickel. So very cool, and they can get way smaller than that as well. Also, a lot of MEMS devices are specifically already in your phones. They're mostly how microphones work these days, and all kinds of stuff. Lots of sensors. So they ran it. They did the tests. They were able to monitor it. Let's see. Yeah, so the center resonant frequency was 430 kilohertz, so it was down than the 500, which makes a slight difference in the stimulation. Here's some more staining astrocyte cultures showing that there was success with the system. So conclusion, we fabricated a new PMUD array with a cell culture chamber for modulation of neural circuits by ultrasound with high spatial resolution in vitro. They demonstrated functionality of the system that a number of responding cells is proportional to the acoustic intensity of the applied ultrasound. Great. We also demonstrated localized stimulation capability with a high spatial resolution through experiments in which co-cultured cells responded only around a working transducer. We envision that our proposed device can serve as a powerful tool to study the effect of ultrasound on neurons and brain circuits and to elucidate the underlying mechanism of ultrasonic neuromodulation. So it could be an important advance in our efforts to conquer neurological diseases. How cool. And then I just want to show off a little bit about what MEMS looks like from a deeper level. These are arguably like nano machine kind of applications where we're talking about gears and levers and mechanical specific systems that are essentially electroplated, chemically plated through the process of manufacture. Wow, it looks like this is cool. It looks like they have the Sandia National Laboratory logo printed right on this. This is really cool. So yes, so this is what that looks like. This is what a MEMS device can look like at the nano machine level. And then I believe if we look here, we can kind of see the future of how much the world already uses things that use MEMS technology. So all of the aspects of everything that you do is already in an embedded sense available. We already have smell, taste, touch, sight, focus, everything, hearing. And eventually, what you'll have is another implant, probably again in the ear, but it stimulates the vagus nerve right through the ear. Or maybe it planted at the base of the skull, so it's more secure, less apt to get jostled, or potentially wrapped around the vagus nerve itself. So that is essentially the future. The future of medicine will likely be some form of a MEMS-style implanted vagus nerve stimulator that probably looks a lot like what we see here, where it's a small, long strip, multi-channel array laid right up across the vagus nerve with a small power pack that's powered externally through a Qi charger, coiled copper. Something of that nature will likely be available in the near future. It's not too far off that this could be something that could be literally just slid very easily like a little wire into the carotid sheath to surround and envelop the vagus nerve. So it's not far off. I really think that that's not very far off. And why you would use something like that? Well, it would probably be for treatment of all kinds of interesting autoimmune disorders. I was just reading another article today about the treatment of, inflammatory symptoms, autoimmune, liver damage, acute kidney failure. There's so much that's treatable through stimulation of the vagus nerve. So it's literally just a matter of time until we're looking at implants such as this. So anyway, just wanted to do a little fun, different style video for today, and I hope that was enjoyable. Hope you learned something. Take care. Bye.